Okay, negative bases. We're going to learn a couple things with negative bases, and we're going to learn how to kind of predict things that happen with negative bases. To do this, though, we need our calculators. So I'm going to pull your calculator out. There's going to be some important things that we do in our calculator to be able to do these things. If you need one, I'll hand it to you. We've got a couple. 1, 2, 3. One. Oh, that was my ball. 2. You got one? Whoa. Awesome. We're going to change these things into 2 different forms. And I'm going to show you how to use your calculator. And a lot of us have different calculators, so you might have to figure out a little bit on your own. The first thing we're going to do is we're going to convert things into factored form. Factored form means like this one up on the board where you change the exponent into how many times you want to multiply something. So if you look at the first question, it says -2 is the base to the power of 1. Factored form would mean that's just -2. And you're not timesing it by anything else. Right? It's just once by itself. There is no operation happening. Standard form is when we actually calculate it. So this equals -2. In this case, factored form, standard form, same deal. Awesome. The second question is a little bit more useful to us. So if we want to change this into factored form, you take the base and you write it out multiplied however many times the exponent is. So for us, it would be -2 times -2. That's factored form. Calculating standard form depends a little bit on your calculator on how you're going to be able to do this. First thing we're going to do is we're going to just calculate it as -2 times -2. We're going to put the factored form into our calculator. On your calculator, you should have a negative button. It's typically down beside the decimal. You don't want to use the subtraction button. Because sometimes, depending on your calculator, it doesn't understand subtract 2 times subtract 2. That doesn't make sense. It knows -2 times -2. So you got to tell your calculator I want to do -2, which is -2, and then times -2. And if you hit enter, you should get 4 as your standard form answer. Positive form. If you want to try to use the exponent feature on your calculator, which is very convenient and easy to calculate things, you must put brackets around your base. So notice how if you look at our power form over here, they have -2 in brackets. You also need to put -2 in brackets if you want to use the exponent in your calculator. For me, my brackets are right here. That's where most people's are. Okay, so I want to open the bracket, so I hit that one, and then I'm going to go -2, and then close the bracket, and then hit squared. For me, my squared button is above my bracket. You on your calculator, it could be in a lot of different places. When I do that, I also get +4. The brackets are going to be key to being able to do things. Awesome. That's the part people mess up all the time. I'll show you in a little bit of why it messes up if you don't do that. If we continue on, we have this question right here. We have -2 to the power of 3. That means you take your base of -2 and you multiply it 3 times. -2 times -2 times -2. That would be the factored form. If you wanted to do the standard form, then you need to calculate that. You could use the exponent feature depending on your calculator, or you could just do the factored form in your calculator. So that's what I'm going to do. I'm going to go -2 times -2 times -2, and I get the answer of -8. Awesome. If you didn't get -8, you got +8, you might have a calculator that works a little bit differently. So when you want to put a negative in front of your number, you're going to actually have to hit 2 and then the negative symbol. And you'll notice it changes to become -2. Then you're going to go times 2 and then do the negative symbol. So you're telling your calculator it's -2. You just have to do the negative afterwards, which is kind of a pain. Awesome. I want you to try to write the factored form for this next one. So see if you can write out the factored form for this guy. Give it a shot, just so we remember what's happening with these. All right, our factored form should look like this. -2 is the base, times -2, times -2, times -2. I do it 4 times because the exponent was 4. That's factored form. If you want to turn it into standard form, which is like just calculating it, right? We call it evaluating it, calculating it. You're going to go -2 times -2 times -2 times -2 in your calculator. You should get an answer of +16. The last one, if you're to do that in factored form, again, you take the base, which is -2, you multiply it 5 times. So -2 times -2 times -2 times -2 times -2. That would get an answer of -32 if you were to do standard form. Fantastic. That's a bit of review, a little bit on how to work our calculators. I want you to try the next column, so all of these questions over here. Try to write them in standard form and factored form. Again, you can follow the same format we just did on the other side if you want, but try all 5 of those on your own. I'll go over it in a couple seconds. So see if you can figure out all those answers. All right, so most people are getting close. We've done at least a few of them. I put the answer up there on the board. Red would be the factored form. Blue would be the standard form. The factored form is just taking the base. In our case, the base was -3 every time. And then multiplying it by itself however many times it tells you to by looking at the exponent. So this one would be 4, 3, 2, 1. The standard form is actually calculating it. In this case, we get -3, then +9, then -27, then +81, then -243. Looking at these answers, what we're going to try to do is notice a bit of a trend here. So the trend is that your answers keep going from negative to positive to negative to positive to negative. Right? If you look at your answers, they keep rotating. The first one was negative, then we calculated our standard form, we got +4. Then we got -8, then we got +16, then we got -32, and it keeps switching. The other thing that keeps switching is your exponent and whether your exponent is odd or even. So if we look, our exponent was odd. Then it was even. Then it was odd. Then it was even. And then it was odd. That's not a coincidence. The reason why this seems to be matching up, where it's always odd produces a negative and even produces a positive, has to do with something you learned a long, long time ago. So you would have learned when you multiply 2 negative numbers, you always get a positive number, right? That means if you were to break this question down and multiply it slowly, when you have an even number of questions, you would have a negative and a negative becomes a positive. But if you have an odd number, a negative and a negative makes a positive, but then you'd have a positive number times a negative number. There's one negative left over. Every time you have an even number, the negative gets erased because the negatives always have another negative to multiply with. an odd number, there's always one negative left over, which turns the whole thing negative. Our general rule of thumb, positive numbers will come from even exponents. So negative bases, they turn positive when there's an even exponent. I think that's written out somewhat for you here. So it says, notice that the standard form of these powers alternates between being negative and positive. Alternates between being positive and negative. That has to do with if it's odd or even. It says the following rule summarizes how to decide if the standard form will be negative or positive. If the base of the power is negative, that's important. So the base is negative, and the exponent is odd, the answer will be a negative answer. Standard form should turn negative. If the base of the power is negative, and the exponent is even, then you should get a positive result. This can help you, this general rule of thumb can help you making sure that you're doing it right in your calculator. Because I know that if I did negative something to the power 4 and then I get a negative answer, I know that's a mistake, right? I should be able to anticipate whether my answer is negative or positive. And that allows me to make sure if I'm right or wrong. Looking at these questions right here, all it wants you to do is write if it's going to be a positive or a negative answer without calculating. You don't need to know the answer. Just will it be positive or will it be negative? That's all they want you to try to do. I'll do the first one, then I'll let the 3 for you. So looking at this first question, I have a negative base, and then I have an odd exponent. Odd exponents mean that I'm going to be negative. My answer should be negative. In this case, it would have been negative 1. You try the next 3. Look at these guys. If I look at B, I have a negative base, negative 1, but then I have an even exponent. That means the negatives are all going to pair up and cancel each other out and leaving me with a positive answer. If I look at C, I have a negative base and an even exponent. That means the negatives should all pair up to cancel out and become positive. The last one, negative base, odd exponent, meaning that there should be one odd one left over after everything pairs up, and you end up with a negative answer. And that one, I don't think your calculator could probably even calculate. Negative 2 to the power of 43 is too big a number for your calculator, so it probably wouldn't even calculate for you. So that would be a really good test question, because the only way to get it right would be to know this rule. That an odd exponent will create a negative answer. And those are the types of questions, yeah, they're good multiple choice ones, are good, numeric response, because you have to know, you can't just calculate it. Cool, we got a bunch of practice questions here for you. Try A and B. If you get stuck on C, that's okay. I'll go over C with you guys, because C is a lot trickier. And then you can try D and E after I show you C if you get stuck. But you can always give it your best shot if you want to just practice it. All right, we're going to look at C together. Before we look at C, I'll just go over A and B quickly. So A and B, you want to write it in factored form, then standard form. Factored form is taking the base. In our case, the base is negative 5. And then multiplying the base by itself however many times the exponent tells you. In this case, 3 times. So it would be negative 5 times negative 5 times negative 5. 3 times. If you put that in your calculator, I know the answer is negative because it was odd. So I got negative. And then 5 times 5 times 5 was 125. So I get negative 125 as my solution. Or my standard form. For B, I'm doing the exact same idea. So I take my base, it's negative 10. I multiply it 4 times because that's the exponent. Negative 10 times negative 10 times negative 10 times negative 10. That gives me positive 10,000 I know it's positive because it was an even exponent. Awesome. The next three, a little bit trickier. Writing in factored form might not be quite as tricky, but calculating it is hard. We'll write the factored form for you. So the factored form would be taking your base. In our case, the base is negative 2 over 5. It's that entire thing. That means I have negative 2 over 5 times negative 2 over 5 times negative 2 over 5. That would be the factored form. Calculating the standard form is a little trickier because our calculators, especially if you're not very good at using the exponent button on your calculator, don't like multiplying fractions very well. These types. Next year you'll get one that calculates it pretty nicely, but this one not so much. So what might be easier is checking to see what the decimal version of this thing would be. If you put just negative 2 over 5 in your calculator, you'll get negative 0.4. And what might be easier for you, instead of doing 2 over 5 times 2 over 5 times 2 over 5, is you could do 0.4 times 0.4 times 0.4. And that would give you the decimal answer. In our case, the decimal answer would be 0.64. 0.64? Thank you. 0.64. Negative 0.64, like you said. Awesome. Now, on tests, sometimes they want the fraction, right? And if you don't know how to do the fraction, that can be really, really challenging. The best way to multiply fractions is you multiply all the top numbers together to get your new top number, and you multiply all the bottom numbers to get your new bottom number. So for us, if I wanted to do the fraction, what I would do is I would go 2 times 2 times 2 to get a new top of 8. Then I could multiply the bottoms, 5 times 5 times 5, to get a new bottom of 125. And again, it would be negative because there was 3 of them, and that's an odd number. You might need to know how to do the fraction way. So multiply all the tops together, all the bottoms together. Fantastic. I'll give you a minute or two to try D as C. For D, you're going to get a decimal answer, and that's fine. For C, see if you can get a decimal answer and see if you can get a fraction answer. So try both for C. Oh, sorry, for E, not C. Looking at these guys. So this one would be negative 1.2 times itself 3 times. So I know I'm going to get a negative answer. Like I can put that down right away without even having to calculate it because there was an odd number of them. Then if I go 1.2 times 1.2 times 1.2, I got 1.728. You don't need to worry about turning that into a fraction. You won't get one like that where they're trying to convert it. At least not right now. For C, the base to C is negative 5 over 2. So you have negative 5 over 2 times itself 4 times. To get the fraction answer, you multiply all the tops together. So my top would be 5 times 5 times 5 times 5, which is too big a number for me.
It's 625.
Ooh, thank you.
Over 16.
And then you would go 2 times 2 times 2 times 2 to figure out what the bottom of your thing is, which is 16. And it would be positive. And it would be positive because there was an even exponent on it. If you wanted the decimal of it, you would change 5 over 2 to a decimal. To change it into a decimal, you just put in your calculator. You go 5 divided by 2. That's what a fraction is. And you would get 2.5. So you'd have negative 2.5 times negative 2.5 times negative 2.5 times negative 2.5. And I don't know what that is.
It's 39.06.
39.0625.
625, so 0.6. I'd be okay if you rounded that to 0.6. That works. Yeah, that would work perfect. Again, they probably want the fraction answer more often than not. But if you want the decimal, that's how you do the decimal. Thank you, Jordan. Cool. The thing that people mess up when it comes to negative powers, because this stuff is pretty similar to what we did yester class, right, on Friday. The thing that makes it different with negatives is whether there's parentheses or not. I never use the word parentheses. I'm using it because the words in here use it, and that's like the mathematically correct term. Parentheses just means brackets. The brackets, when it comes to exponents, are very, very important. The brackets are telling you what the base is. If there is no brackets, then you assume that anything outside of the very first number next to the exponent is not a part of the base. So for instance, if you look at this question right here, we would assume that to be -1 times 4 to the power of 3. That's how I would look at that. The negative actually represents a -1, and it actually represents a coefficient, like another number in front. So with no brackets, the negative actually stays out on its own, and the base to your question is just 4. And that 4 has an exponent of 3. This changes things dramatically. So how it changes it is when you write things in factored form, this would not be -4 times -4 times -4. In factored form, this would be negative, and then it would be 4 times 4 times 4. This means that the exponent wouldn't affect whether the entire thing was positive or negative, because the negative symbol was by itself. My standard form for this thing would be negative, and then if you go 4 times 4 times 4, you get 64, I believe. So your standard form is -64. Awesome, we'll do another one like that. So if you look at the next question, we have -10 to the power of 8. There's no brackets. Because there's no brackets, that means this is really -1 times 10 to the power of 8. That's really what's happening here. The negative is its own thing. The base to this is just 10. And the exponent is 8.
Could you do -10 and then just 8 times?
Yeah, I think so. I think that, if I'm understanding what you're saying, yeah. So in factored form, the way this would look is you would have a negative out front as the first thing, and then you would have 10 times 10 times 10, and you're going to do it 8 times. Like that. Notice that there's only one negative in this entire thing now. When I said that this idea that we're learning today continues on like all the way through math, this is the part of the idea that continues on all the way through math. And people continually in grade 10, 11, 12 make this mistake. And they think that negative is a part of the base, when in fact it's not. It's in front of the base. In standard form, your calculator might not be able to do that one. Did you just do it? Yeah. So if it does do it, that's wonderful. If it doesn't do it, when you're multiplying tens, the trick is that however many zeros there are, so in our case there's 1, 2, 3, 4, 5, 6, 7, 8 zeros, that's how many zeros you should have in your answer. So my answer would be negative, and then 1, 2, 3, 4, 5, 6, 7, 8. My answer would be 100 million, -100 million. Do all your calculators do it? Yeah. Somebody put nodding yes. Anyone nodding no? Okay. Sometimes the numbers get too big, right? Like if there's too many placement values, it gets too big and your calculator won't put it down anymore.
It does the other
Yeah, or it'll do like that negative.
It goes -1 and then a big space and then 10 for zero.
Yeah, so like yours tells you how many zeros you need. Yours says error.
Mine was like times 10 over a power. So
Yeah.
It was like too many numbers. It was like times whatever.
And that's telling you like how many times to move the decimal place to the right of whatever it gave you. And as you get into fancier calculators, it'll start to say, you'll say the letter E on it, and it'll change things. So the best way to just know is however many zeros there are, that's how many you're putting. Awesome. This is important. Very, very, very important. Understanding that the negative is not a part of the base if it's outside the brackets or there are no brackets. It says it kind of down here. Notice that the standard form for questions when there's a negative without parentheses just means brackets, is always negative. So if there's no brackets, the result's always negative because the negative was aside from the question. And standard form for questions with parentheses just means brackets, depends on whether the exponent is positive or negative. Wonderful. Seeing how this makes a difference. We're going to look at two things that look almost identical but are actually quite different. We have -2 to the power of 4 and then brackets -2 to the power of 4. Brackets are parentheses. That's the same word. If we wanted to write it in standard form, the first one is actually negative. It's not letting me write. You have to give me one.